the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siyaya. Kubeka, let's learn the new way. Siyahamba pezul. Daily dose of power. AI's here. Siyaya. Kubeka, let's learn the new way. Siyahamba pezul.
Hi guys, welcome to another lesson of the Daily Dose of Mathematics. In our question today, we are doing 6.2 from the June 2026 Limpopo question paper. It said I speak a little bit faster, so I'm going to try to be a little bit slow. If you feel the same way, guys, you can comment fast so that I can try to adjust my pace. Now, remember, at the Daily Dose, we're going to be using our senior marker. We're also going to be playing a power rule song. Itu, you can take us through our question.
So then, since we are dealing with 6.2 today, we are going to differentiate the following with respect to x.
Okay, in this question here, guys, we're supposed to use rules, unlike the one that we did on 6.1. On 6.1, we're using the first principle.
Yeah, we're using
so with this one here, we're going to be using the rules. It's a little bit simple, but the trick here is that we need to know some of the things that we need to prepare our question before we can differentiate it. That might be a little bit of a challenge because you need to learn a little bit of algebra from earlier grades. So let's start with the first question. It's 6.2.1. 6.2.1. Okay, what do they say?
By which 6.2.1 says y is equivalent to 2x squared.
So y is equivalent to 2x squared, yeah.
Minus 11.
Minus 11.
X.
Minus 11x, yeah.
Plus 15.
Plus 15.
All over.
All over.
3 minus x.
It's 3 minus x.
By which x cannot be equivalent to 0.
Okay, x cannot be equivalent to 0. Here, guys, that just trying to say if you put x as a 0, there's going to make this
sorry, say x cannot be equivalent to 3.
X cannot be equivalent to 3. Yes,
yeah.
They're trying to tell us that if we put 3 here, it's going to make this thing here to be undefined.
Yeah.
So that's just a restriction to keep us sane, to say if you put any 0 there, if you put any 3 here, you're going to have undefined. Okay. With that being said here, with this question here, guys, it's what we call we're going to look at our denominator.
Yeah.
The way you approach calculus is that you need to look at your denominator. If you have a denominator, it's either you can have a binomial or you can have something with one term.
Yeah.
Now, if you have something with one term, let's say you have, you can write it down there. Let's say you have 4x squared plus 6 all over x. Now, if you look at this one, the expression that I just gave you now, it only has one term.
Yeah.
Now, if you have one term, you are going to split this thing here. You are going to write it in 2 different bases. So it's going to be written as, can I say it's 4x squared?
Yeah.
Plus
6
all over
x.
All over x. So we are going to write it as 4x squared all over x.
All over x.
Yeah, and then you're going to say plus 6 all over x. So I can write these 2 different things. I can the ones on the numerator.
Yeah.
I write them in their own base. This question here, you cannot approach it that way because you have 2 terms on the denominator. So it's a binomial, trinomial. So what you need to do with this one here, we're going to look at the numerator here.
Yeah.
When you look at the numerator is going to be something that we have to factorize. And then we're going to try to factorize it such that it looks like the denominator.
Yeah.
So it means that if you check this thing here, it's a quadratic. Okay.
Yes.
So let's try to check this thing can be factorized. We're going to open 2 brackets. So it means that you're going to tell them that you have y
is equivalent to?
Is equivalent to. Now let's open 2 brackets. Now if you open 2 brackets, they said we have 2x squared.
Yeah.
Minus
11x.
Minus 11x.
Plus 15.
Plus 15. So let's start with the factors of 2x squared.
Yeah.
So factors of 2x squared, you're supposed to have 2x and an x. Okay?
Yeah.
Now, with that being said here, now we are going to look then for, remember, it's 2x squared.
Yeah.
Minus 11x.
Minus 11x plus 15.
Plus 15. So if it's plus 15 in our brackets, we're going to have a minus and a minus.
Yeah.
Because you are supposed to say negative and a negative, and then it's supposed to give you
a positive.
A positive. Now, what is the guiding thing here? Remember, factors of 15, like I can only as much as, there are not that many factors of 15, but I'm guided by the denominator. I'm going to be looking at the denominator. That's what I'm going to be keeping my mind on. So if you look here, you have something on the denominator. You have 3 minus x. Okay?
Yeah.
Now, if it's 3 minus x, I'm going to try to make sure with one bracket, one of the brackets, it needs to have x minus 3. This one already has 2. I can't put 3 here because if I put 3 here, it's not going to give me that anymore. So it means, in other words, I'm going to say I'm going to use a factor of 15 that has 3 on it. So I need to say 3 and 1 so that I can get 15.
Okay.
It's 3 and 4. If I say 3 multiplied by 5, it gives me 15.
It gives you 15.
Yeah. So inside my brackets, the 3, I'm going to put it with this bracket because if I put, like you will see, even if we multiply it, it's still going to give us that thing. So I'm going to have minus 3. And then I'm going to have plus 5.
Okay.
Oh, it's minus 5. It's minus 5. Yeah, it's minus 5 and then it's minus 3. Now let's just not try to be heroes and just confirm it. Again, I'm going to say 2x multiplied by 3.
Yes.
It gives me minus 6x.
And
I say minus 5 multiplied by x gives me minus 5x. Yeah. So you see these things, they give us the middle term. Okay. We're going to try to continue with this. Now, as you can see here, we have a problem because the other one says x minus 3 on the numerator.
Yes. But
the denominator one says 3 minus x. It's a problem.
Yes.
But there's a way in which we can make those two things to look alike. By factorizing this, we're going to take out a negative as a common factor on the denominator.
Okay.
So let's write our numerator. On our numerator, we're going to tell them that we have y is equaling to open bracket.
2x.
It's 2x minus 5.
Minus 5.
Close bracket.
Minus x minus 3. X minus 3.
Yeah, and then we open another bracket here.
All over.
X minus 3. Yeah, and then all over, we're going to say minus open bracket. Does that make sense?
Yes.
Yeah. And then once we do that, whatever was positive is going to become negative. Whatever was negative is going to become positive. So in this case, we can write it as x minus 3. I got 3 was positive.
Yes.
Now the 3 is going to become what?
Negative.
And then the x was negative. Now it's going to become what?
Positive.
As you can clearly see now, there's something that looks alike on the denominator and also on the numerator. So we're going to divide them out. So we say divide.
Yeah.
All right? Still fine. Okay? So what are you remaining with now? You are remaining with 2x. Okay?
Yeah.
Minus 5.
2x minus 5.
All over minus 1. Don't forget that you still have minus 1.
Yes.
Yeah, you can take this minus 1 and multiply each and every term with the minus 1, or you can do what I was just showing you, because now you have 1 term. Okay?
Yeah.
You can write them into, because remember, multiplication and division, they're both going to give us the same results.
Yes.
So in this case, I will say let's split this basis, so that you're going to have y, which is going to be equaling to 2 all over x divided by minus 1.
2x all over minus 1.
Yeah. 2x all over minus 1. And then we have minus again.
Yeah.
We have 5 all over minus 1. So that it becomes clear to you how did we get this thing to be negative. Right?
Yes.
So we say equals to positive and the negative, it gives us
negative
2x. Okay?
Yes.
Negative and a negative, it gives us
a positive
plus 5. It's fine. Okay?
Yes.
Now we can then differentiate. You see this, all these things that we're doing here. We're not differentiating. We are just getting this thing to be ready to be differentiated. That's the tricky part. Differentiation is not a challenge. The challenge is getting it ready so that it can be differentiated. Okay, now it's ready to be differentiated. Slow. Okay. So we have dy all over dx. Again.
dy all over dx.
Which is going to be equaling to minus 2.
Minus 2?
Yeah. Now, how did you get the minus 2? Again, we use the power rule.
Yeah.
We said 1 multiplied by negative 2.
Yes.
It gave us negative 2. And then maybe for people who are not familiar with this, we can say we have 1 minus 1. Right?
Yeah.
And then if we have 1 minus 1, then we're going to have x to the power of 0. Right?
Yeah.
The 5 doesn't have an x, and then we're differentiating in terms of x. Right? Yes. So it becomes a constant. So we're going to say plus 0.
Okay.
And then we tell them what dy all over dx is going to be equaling to any number to the power of 0. We are going to have 2 multiplied by 1. Just making unnecessary steps here. Minus 2 multiplied by 1.
Yes.
And then it says dy all over dx is going to be minus 2. I hope I was slow, guys. Just tell me if I did it.
Do you realize how I say mistakes too fast? You just keep another step, trying to be a hero.
Okay. So we're going to have dy all over dx is equal to minus 2.
Yes.
Okay, guys, we're going to play the power rule song. While we're playing the power rule song, we're going to take our solution, put it in the senior marker, and then here the senior marker, how we critique Let's dance, guys.
Listen close, it's time to derive. We're making the calculus come alive. Before you touch that DAX, you gotta prep the work, reduce the stress. If you see a root, don't leave in the dark. Change it to a fraction, that's your starting mark. Set the exponent right, then it's plain to see. And if there's a denominator, look at the base. If it's one
Final
single
score,
term,
3/3 marks. Here is the official evaluation of your work presented in image_581 FA6 link to .png. Marking breakdown. Step. You're working. Mark allocation. Reason 1. Y equals frac 2x5, x3, x3, dots y equals minus 2x plus 5. 2 marks, M, CA, method and consistent accuracy, standard algebraic processing applied. Initial factorization and denominator sign extraction correctly simplify the rational function into a standard linear format. 2. Therefore, frac dy, dx, equals minus 2 1 mark, A, accuracy. Final differentiation transformation yields the correct constant derivative. Corrective feedback. Your logic is mathematically robust. You successfully identified that the complex rational fraction needed to be simplified using factorization and a sign change operation in the denominator before applying differentiation rules. Because your algebraic manipulation and final derivative are entirely correct, no Socratic intervention is required. Caps and formal notation compliance. Derivative notation. You correctly switched from y equals dots to frac dy, dx equals dots at the exact moment you applied the differentiation rules. This is a critical caps requirement that you executed perfectly. Sign change technique. Extracting the negative from 3x to create x3 in red ink demonstrates a clear, formal understanding of polynomial manipulation necessary for algebraic fractions. Coach's summary. What you did well. Your method of dealing with the denominator, 3x, by factoring out a minus 1 to force a cancellation with the numerators, x3, bracket is textbook perfect. You simplified the expression completely before attempting to differentiate, which is the safest and most efficient exam strategy. Area for improvement. While mathematically correct, breaking the fraction into frac 2x minus 1, frac 5 minus 1, is an unnecessary intermediate step that consumes valuable exam time. You can jump straight from frac 2x5 minus 1 to y equals minus 2x plus 5 in a single fluid motion.
Okay, guys, we're going to go to 6.2.2.
Yes.
Okay, what does 6.2.2 say, Itu?
So the 6.2.2 says y is equivalent to open bracket
Y is equivalent to open bracket, yeah,
x squared
x squared
minus
minus
square root of x
root x, no?
close bracket
Close bracket,
all squared.
whole square. Okay, here, guys, as you can see, we're dealing with a bracket that we're supposed to expand. No?
Yes.
Not only that, we're also dealing with a root. No? So they gave us root x. Okay?
Yes.
Remember, the song specifically said if you are dealing with a root, we need to change it so that it becomes an exponent. Okay?
Yes.
So we're going to have y. No?
Y.
And then remember, the squared means repeat the bracket 2 times. No?
Yes.
So we're going to have x squared minus x, and then we are going to change the root. Instead of a root, it's similar to writing x to the power of 1 all over 2.
X to the power 1 all over 2.
Yeah, and then we close our bracket, and then we do it again. We have x squared minus x to the power 1 all over 2.
Over 2. Close bracket.
Yeah, okay, guys, here we're going to be using exponents laws, and then which we started doing them from as early as grade 7. Now, the mistake that learners most of the time make is that they forget, and then they tend to multiply the exponents. We don't multiply the exponents, guys. Multiplying powers of the same base, we add the exponents. Just remember that, which we are not multiplying, we're adding the exponents. So if we say x squared multiplied by x squared, okay?
Yes.
What is it going to give us?
X to the power 4.
Yeah, how did you get x to the power 4? We said 2 plus 2. Ne?
Yes.
Then it gives us x to the power 4 sharp. Now next we're going to have x squared multiplied by minus again.
Yes.
X to the power 1. You can just do a line just to show which one I will multiply in there. So we have x squared multiplied by x to the power minus 1. And then what did we say? We said we're adding the exponents again.
Yes.
So basically we have 2 plus
2
1 over
plus
2.
2 plus 1 over 2.
Yeah, so we're going to have minus x to the power of, if you say 2 multiply, it's like you're saying 2 plus a half, but we're going to
Yes.
get 2 and a half. Now what is 2 and a half? It's 5 all over 2. Yeah.
So then we're gonna have
And then we do this one now. We have root 1 all over 2 multiplied by x squared. Okay?
yes.
What do you get?
Minus 5 all over
Minus,
2.
yeah, we get minus 5 all over 2. Sure. The last one is negative and a negative.
Yes.
Then we get a positive.
Positive.
Yeah.
And then
Yeah, remember, we're adding the exponents. This is another mistake. I've seen this most of the time. Learners will say it's x to the power 1 all over 4. That's wrong, guys. No? We're going to be adding the exponent. We say half plus a half. If you have a half and then you add it with another half, what are you going to get?
a 1.
Yeah, you're going to get a loaf, a full loaf. Okay. So now, in the middle here, as you can see, we have something that we call like terms. Okay?
Yes.
Now, how do we know with their like terms? They have exactly the same base and then they also have exactly the same exponents. Right?
Yes.
So that's how we know which they are like terms. So we're going to have x to the power 4. Okay?
Yes.
Minus, add these two things here. They're going to give us 2. Ne?
Let us not try to be heroes.
Yeah, that 2 is 2. It's 2
It's
x.
2?
Yeah, it's 2x to the power of 5 all over 2. Remember, we are just adding, the exponents are going to remain the same. If you're adding, now this thing here, it's a law of addition. It's no longer a law of multiplication. I get.
Okay.
On the law of addition, we just look at the exponent. If the exponents are the same, let's say we have x to the power of 1 plus x to the power of 1. Right?
Yeah.
So we're going to say x and x, but both of them, they're exactly the same exponent. So they're going to give us 2x. Yeah.
2x to the power 5 all over 2.
Yeah, so we're going to have 2x to the, you're going to have minus 2x to the power of 5 all over 2. Yeah. And then we have plus
X.
Yeah. Now, guys, you can see we've prepared our equation. Now it's ready to be differentiated. Ne?
Yes.
Now then, after this, this was y, this was y, this was y. Then we're going to bring in the notation now. We're going to tell them that it's dy all over dx. Using the rules, okay?
Yes.
First one, it's 4 multiplied by 1, okay?
Yes.
4 multiplied by 1, we get
4x.
You get 4x, okay?
Yes.
Then you say 4 minus 1 on top, okay?
Yes.
Yeah, so we first start by multiplying with the exponent, then we subtract. No?
Yes.
Next, we're going to say we have 5 all over 2 multiplied by minus 2.
Yes.
And then you are going to be left with something like minus 5.
Minus 5.
Yeah, and then it's x, okay?
Yes.
And then we have 5 all over 2 minus 1.
Yes.
Sharp. Okay, the last one we have 1 multiplied by 1, okay?
Yes.
So it says it's 1 multiplied by 1, it gives us 1. And then we have x to the power 1 minus 1.
Yes.
Sure. Okay. Now trying to be slow. So we have 4x and then it's 4 minus 1. Yeah?
Yes.
So it's going to give us 4x cubed.
4x cubed.
Sure. And then with this one, we already said we have minus 5. Okay?
Yes.
Minus 5x. Now, if you say you have 2 halves, okay?
Yeah.
And then you subtract 1.
Mm-hmm.
So you have 2 and a half and then you subtract 1. What do you expect to be remaining with?
2 and a half and then
you subtract 1. You're going to be left with, let's say you had 2 and a half things. You just take out 1.
Just take out 1 and then I remain with half.
You're going to be remaining with 1 and a half. Because I agree you had 2 halves things. So
I had 2 halves.
Yeah, you had 2 halves and then you say take out the 1. If you take out the 1, you're still going to be left with 1 and a half. You can type it in your calculator if you're not sure, guys. This is going to give us 3 all over 2. Because it's 1,5. So we had 2,5 and then we subtracted 1. If you say 2,5 minus 1 is going to give us 1,5.
Yeah.
Sure. And then this one here, it's any number, again, it's going to be 1 minus 1. One. Any number to the power of 0 is going to give us 1.
Yes.
And then we are done with this one. Now, guys, this is the last time you hear my voice, my first voice. So if you like what you are doing, don't forget to like our page. We are on Facebook, we are on TikTok. We're going to be playing the song, putting this thing here on our senior marker. Remember, guys, if you want the prompt of the senior marker, just request it on the comments. Yeah, just play the song.
It all over the place. But if there's two terms down there, stop the flow. Factorize the numerator, that's the way to go. Now we move to the rule, the power of the game. Exponents multiply the front, it's never the same. Bring the power down, let it multiply the floor. Then subtract a 1, don't ask for any more. And x and 1, shout it loud and clear. That's the derivative that conquers the fear. That's the derivative that conquers the fear. Now check for the constant, looking for the x.
Final
If there's
score,
no X
4
inside,
quarters
don't-
marks. Here is the official evaluation of your work presented in image_583667 link to .png. Marking breakdown. Step. You're working. Mark allocation. Reason 1 to 3 y equals x squared x caret frac 1, 2 squared dots y equals x caret 4 to 2x caret frac 5, 2 plus x. 2 marks, M, CA, method and consistent accuracy, standard algebraic processing applied. Initial logic to convert the surd to a rational exponent and expand the binomial is validated and simplified correctly. 4, therefore, frac dy, dx, equals 4x cubed 5x caret, frac 3, 2, plus 1. 2 marks, CA, A, consistent accuracy and accuracy. Final differentiation transformation yields the perfectly correct derivative for all terms based on your expanded polynomial. Corrective feedback. Your mathematical logic is flawless. You perfectly executed the fundamental rule of calculus preparation. Always clear fractions, surds, and brackets before attempting to apply differentiation rules. Because your expansion, algebraic simplification, and final derivative application are entirely correct, no Socratic intervention is needed here. Caps and formal notation compliance. Derivative notation. You executed the notation switch perfectly. You kept the equation labeled as y equals dots while you were algebraically manipulating the expression, and strictly changed to frac dy, dx, equals dots on the exact line where you applied the power rule. This is a crucial caps requirement to avoid penalization. Rational exponents. Converting sqrt x to x caret frac 1, 2 is the formal and correct approach required by the syllabus to differentiate surds. Coach's summary. What you did well. Your use of the FOIL method, indicated by your red and green arrows, to explicitly track the expansion of x squared x caret frac 1, 2, x squared x caret frac 1, 2 is an excellent strategy to prevent dropping the middle term. Managing the fractional exponents during multiplication, adding frac 1, 2 plus frac 1, 2 equals 1 was handled flawlessly. Area for improvement. While showing your exponent subtraction explicitly, frac dy, dx equals 4x caret 4 to 1 dots is mathematically valid and safe, it is not strictly required for marks in grade 12. As you gain more confidence and aim to optimize your exam time, practice doing these basic subtractions mentally and writing down the final derived term directly.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064